Alright students, this is page 97, example 8.8, and we already did it, but I wanted to illustrate how to do hypothesis testing when sigma is known with your calculator. A graphing calculator can do a hypothesis test, and you'll have to go into its stat menu, and then you'll have to ask it for its testing menu. And then, because we're doing mu and sigma is known, we perform a z-test. So we bring up z-test. We don't have raw data, however we have statistics, so select stats. Mu naught is what they were claiming, which was 41, I believe. Sigma is the value they gave us. It's the population standard deviation, so enter 35. X bar was given to us as 47. N in this problem was 40. And our alternative hypothesis statement was testing a greater than symbol. So we're going to scroll over and select the greater than symbol. And then we're going to hit calculate. A p-value is reported to us. So in green marker, I'm going to do over here the p-value. I'll write it down. Calculator is telling me it's 0.1391. Now in a hypothesis test, when you have a calculator like this, you need to do step 1, which is write the hypothesis. But instead of the test statistic and the critical value, you're going to write down the p-value, and then you're going to compare it to alpha. And if p is less than alpha, you reject h0. That's the rule that we discussed when we talked about the p-value method in general. So you look at the p-value, 0.1391, and you compare it to your level of significance, 0.05. In this case, the p-value is greater than alpha, so we are going to fail to reject h0. Okay? Which is the decision we came to when we did the critical value method approach as well. And we would come to the same conclusion. If you fail to reject h0, you're going to say, based on the evidence, the mean number of sunspots during the Spanish colonial period was not significantly higher than 41 at alpha equals 0.05. Okay? So that is how you can do a hypothesis test when sigma is known using the power of your calculator and the p-value method.